For our third example, we are talking about a right angle triangle and we are told that the hypotenuse is 109 centimeters. So let's draw a right angle triangle here, maybe. All right, let's see if I can grab the right tool this time. There we go. Let's try this. All right, so here's my right angle, and joining that together, it would be much better if I actually used a ruler, but you know, this iPad thing, not exactly convenient on Explain Everything. All right, so I have my hypotenuse marked as 109 centimeters. It's always the side across from the 90 degrees, of course, and one leg is 2x centimeters long. The other one is 3x plus 1. So 2x's is probably shorter than 3x's plus 1. So I'll mark my two legs, or other sides of my triangle, to be that. What are the lengths of the legs? Well, what we're going to use here is something that applies to right angle triangles. We know that the Pythagorean theorem, a squared plus b squared, has to equal c squared. The Pythagorean theorem holds true for a right angle triangle. So the c, remember, is your hypotenuse, and your other two sides are the a and the b. So really what we have is 2x squared plus 3x plus 1 squared equals 109 squared. Oh, let's see what we can do with this. Well, we're going to have to simplify this. So 2x times 2x would end up being a 4x squared. Now you can be nice and write 3x plus 1 out twice, or you can use the shortcut, which is square the first. So 3x to the exponent of 2 is 9x. Double the product of these two terms. 3x times 1 would be 3x, and if I double that, I'm going to get a 6x. And square the last. 1 times 1 is 1. And that's going to equal 109 to the exponent of 2, which is 11,881. And I used my calculator to do that. I didn't know how to do that in my head. I don't know that one. All right, collecting like terms, 4x squared plus 9x squared is 13x squareds plus 6x. And then while I'm at it, I'm going to subtract the 11,881 from 1. And of course we have minus 11,880. And that's equal to 0. All right, now I'm looking at this, and it's a trinomial. I don't see any common factor here. 6 doesn't divide the 13 evenly, so you know, we're out of luck here. It is going to be a tricky trinomial. We're looking for two numbers that will add to 6, and at the same time, they have to multiply to negative 154,440. Oops, undo. There we go. I'm just trying to move this over a little bit because I can't fit that whole number in there. Let's try this again. 440 is on the end of that. Okay, and that's a negative value. So that means my signs of my numbers are different. One's positive, one's negative, and they're only different by 6, positive 6. So what I'm going to do is I'm going to actually square root, not the negative because I can't square root a negative number, but I'm going to square root 154,440, and that gave me about 393-ish. So let's try dividing by something close to that. Let's try dividing by 390. I'm going to take 154,440 and divide it by 390. And I get 396, which is lovely because if I make my 390 negative and my 396 positive, I now have a difference of 6 between those two numbers. Perfect. So we can now decompose the middle term. Minus 390x. I'm going to put the 396, I think, with that because, let's just check. 390 divided by 13. Oh, it does go evenly. We're good. No problem. All right, plus 396 minus x minus 11,880 equals 0. Pair the first pair up. 13x is common, leaves you with an x and a minus and a 30. Plus, I'm going to guess 396 will divide 11,880. Yep, good. Whew. And that goes in 30 times. And that's equal to 0. So now x minus 30 is common, and it leaves us with 13x plus 396 equaling 0. Set our little factors equal to 0 and solve for x. So x equals 30, or we get 13x plus 396 equaling 0. So 13x's will equal negative 396. Divide both sides by 13. We get negative 396 divided by 13. 396 divided by 13 doesn't go evenly, so I'm going to leave that as a fraction. Now, let's think about this for a moment because we need to know the lengths of the legs. If I had a negative value for my x, like I do in the second example, when I do 2 times that negative value, it would give me a negative length for my side here. Likewise, 3 times that negative value and then add 1 would give me a negative length for my other side. So this one does not make sense. We can't have a negative length. So this is an extra answer that doesn't make sense for the context of the question. Can't have negative. I got the length. That's supposed to say negative. All right, and then my 2 sides, if I do 2 times the x, which I get as 30 here, 2 times 30 gives us one side being 60 centimeters, and the other side is 3 times 30 plus 1, which is 91. So my other 2 sides, the lengths of the legs, are 60 centimeters and 91 centimeters. And of course you can try 60 squared plus 91 squared and see if it gives you the hypotenuse, the 109 squared there, and it should. All right, one other example here to do, which is similar to ones we've done before, but it doesn't hurt to review them again. Okay, for this example, we have a ball being hit off the roof of a building. Its height in meters is represented by the equation I've given to you here, where t is your time in seconds since it was hit. So h is your height and t is your time in seconds. Part A says, what's the initial height of the ball? So we are being asked for height. So what is the initial height? Height is equal to something. When we talk about the initial height, we're really talking about the starting height. It's the height when time equals 0. So if we sub a 0 in to our equation, wherever there's a t, we get the initial value, or the y-intercept, or in this case the h-intercept, and that's at 30. And if you remember from our summary sheet, we talked about the c value. The c value in our equation is the initial value, or the y-intercept. So it's going to start from a height of 30 meters. So it's on the roof of the building. The building must be about 30 meters tall. Okay, so I finished that question up with a therefore statement. Part B says factor the function. So we're going to factor this. Always look for a common factor first, and I believe everything could be divided by negative 5. And I like to divide out the negative with the 5 just so that my t squared is a positive value here. And then when I divide each thing by negative 5, I'm left with this as my trinomial, which is a simple trinomial. And I'd be looking for 2 numbers that are going to add to negative 5, and at the same time they have to multiply to negative 6. So how about negative 6 and positive 1 for that? And because it's a simple trinomial, we can go right to that factored form of t minus 6 with a t plus 1. All right, and part C says, when does the ball hit the ground? So it's asking the when, so it's t you're trying to figure out, and if it's hitting the ground, the height is equal to 0. So it's really a quadratic equation that we need to solve here. And I'm going to use my factored form since we already have that. And we have our factored form here from part B. So that gives us that t minus 6 equals 0, or t equals 6. And t plus 1 equals 0. And that means t equals negative 1 when we get t by itself. Now this second one, t equals negative 1, doesn't make sense. You can't have a negative time. So time can't be negative. So that means it's going to hit the ground 6 seconds after the ball was hit. All right, it hits the ground 6 seconds after it was hit. For what values of t is the function valid? So we talked already about the fact that we can't have negative time. So it means t has to be greater than or equal to 0, because we can't have a negative time. And this function, this parabola, only makes sense until the ball hits the ground. So it's only going to make sense up until t has to be less than or equal to 6. Okay, it only makes sense up to the point it hits the ground. Another way of writing that, to say t is greater than or equal to 0 and has to be less than or equal to 6, another way to write that is to say 0 is less than, smaller than, or equal to what t can equal, and t has to be less than or equal to 6. So we're really saying that t is sandwiched between the values of 0 and 6. Okay, so those are less than signs in between there, along with equals. All right, the last one here, when does the ball reach the maximum height? So graphically, we know parabolas are symmetrical, and we have the zeros theoretically at -1, although that doesn't make sense for context, and again at 6. So in theory, our parabola would look like this. Again, we only really want to look at the part of the parabola right here up until this point. But because of symmetry, we know that the vertex, the time that we're going to get the maximum height, it's going to be in the midpoint or the halfway point between -1 and 6. So we're going to add those two times together, so -1 plus 6, and divide by 2 to get the midpoint. So that's going to be 5/2 or 2.5 seconds. So at 2.5 seconds, it's going to reach the maximum height. And then to get the actual height, you just sub that into one of the forms of your equation. So you can either go back to the original format, -5t squared plus 25 times the t plus 30. Or you could sub it into your factored form that you figured out earlier. And when I put that all in my calculator, I got an answer of 61.25. So the maximum height of the ball is 61.25 meters, and it occurs 2.5 seconds after the ball was hit. So there we have it, a familiar application, but just pulling the ideas together from our previous sections.